Okay, we have a situation where we got a cosmonaut or astronaut, whatever you want to call it, uh, who jumps from a spaceship in order to meet a co-pilot who's floating at rest a few hundred meters away. Turns out in this problem, we don't really care about the fact that our co-pilot's a few hundred meters away because we know what speed she jumps off the ship and we want to know what the resulting motion of the ship is. Okay, so we know that she jumps off with a speed of 10 meters per second. That doesn't tell us the direction, so maybe we make up a direction. So let's, first off, let's draw a picture of what's going on. Let's make it a spaceship. Okay, so I guess it's a flying saucer. And here's Cosmonaut. Here's her face inside her giant helmet. Okay, and she's going to jump off. So initially, both of these objects have zero velocity, zero initial velocity. And then afterwards, it looks like this. She's going to jump off this way. Zoom. And she's going to have velocity this way. And the spaceship is going to have velocity this way. Okay, she's going to jump off, and because the spaceship's in space, there's nothing to resist it. We're assuming all the engines are off, and as she jumps off, it's kind of like if you've jumped off of a boat, you'd feel a similar type of behavior, where it would slide backwards as you go forward. So we know initial velocity is 0, so we need to figure out the velocity of the spaceship final. So let's call it spaceship, velocity spaceship final. And we do know the velocity of Cosmonaut final because they tell us the speed is 10 meters per second. And we've actually drawn it in a positive direction, so let's keep it positive. 10 meters per second. Okay, so because of conservation of momentum, the initial momentum must equal the final momentum. The initial momentum of all the objects that are interacting have to equal the final momentum of all the objects after their interaction. So we have both of these have a velocity of 0, so it doesn't matter. Their mass times velocity is equal to 0. So we're going to have an initial momentum over here of 0. And here it is written out. Velocity is 0, so that's 0. Velocity here is 0, so that's 0. So we have a initial velocity on this side of 0, total 0, equal to. Now we want to figure out. We need to figure out the velocity of the spaceship final because we know the velocity of the cosmonaut. So we'd expand our P final to look like this: mass of the spaceship times velocity of the spaceship final plus mass of the cosmonaut times velocity of the cosmonaut final. And we'd plug in our numbers. Plug in our numbers, and we will solve for the velocity of the spaceship final. Subtract 600 to the other side. Divide both sides by 5,000, and the final velocity of the spaceship is equal to negative 0.12 meters per second. So about 12 centimeters per second. Not very fast. But notice that it's negative, it's in the opposite direction. But you do have some, it doesn't seem like it would move at all because it's a big giant spaceship. But there is, that the spaceship has to move the other way because of the person jumping off.